now we are going to the next topic in the same multiple linear regression. The extension, we have completed linear regression. We have completed overfitting, and we are actually going into the next cross validation in practical. Now we are moving to the next theoretical derivation part, that is multiple and partial correlation in regression items. This is what we are going to see in today's class. Now the most important thing when we go with multiple linear regression, we have seen how the multiple linear regression parameters are estimated by using least square estimates as well as maximum likelihood estimate. But even though these parameters are also being estimated, there is some dependence between independent variable and dependent variable, and always when we take a group of independent variables, we will be having a tendency to make any one to go out, because we don't want to take all the independent variables, though they are significant. We don't want the influence of any one independent variable on the dependent variable. So there should be something like if I go for multiple correlation between independent and dependent variables, I should take everything. Or in partial correlation, I should be in a position to remove any one of the independent variable. So I should be able to do that. That is what we are going to see, how to leave a particular independent variable from the estimation part. That is what we are going to see. Right? This correlation can simply be identified from its very basic, right? Correlation between independent variable I and dependent variable D. So this is what we are going to take as a base, and using this base we are going to see how to do multiple correlation and how to do partial correlation. What are the terms, what are the types available, everything we are going to see. What is the correlation between an independent and dependent variable is nothing but we denote the correlation as R, right? We actually usually do that. We denote the correlation as R, and the correlation between an independent and dependent variable can be expressed as, I'll increase the size, say R I D or DI, sorry. So dependent variable D and independent variable I. There are two variables, and I need to take the correlation between these two variables, right? The thing to understand here is it is not that only two variables that are dependent and independent alone need to be correlated. Their correlation should be very high, and the correlation between two independent variables should not be as much higher, right? So that is what that we already know. Right now I'm taking this. This can be expressed by using the formula summation xi. The xi is nothing but the extra independent values. First we wrote d, so we'll be writing d here now. xd, that is the input values of x corresponding to x, and xd xi whole divided by square root of summation of xd the whole squared minus summation of xi the whole squared minus summation xi squared. These values usually we will be getting when we construct the regression table. For even a linear regression table, when we construct, we will be getting all these xd, xi squared, xd squared, every values we will be getting, and we will be deriving the correlation b1 value, right? We will be calculating the b1, right? So that is summation x minus x bar the whole square divided by summation x bar the x square the whole square, right? That is what we will be doing there. The same thing is actually being done here, but with some dependent variable and independent variable, right? This is not our point of interest actually. By using this particular correlation formula, we are going to see how multiple correlation is going to happen. One thing is extra in multiple correlation, that the number of dependent variable will be one, but the independent variable can be more than one. So what we do, we have to have a formula in such a way that when a particular variable is going to depend on two other variables, that is actually multiple correlation, right? So now we'll see multiple correlation. Variable 1 is dependent on variable 2 and variable 3. Variable 1 is dependent on variable 2 and variable 3. So I need to have a relation like that. How can I represent a correlation between variable 1 with respect to 2 and 3 is I can represent it as R 1.23. If I represent 1.23, it is not 1.23, it is 1.23, means that there is a dependent variable 1 which is dependent on 2 and 3 independent variables. This is actually the correlation of 1 with respect to 2 and 3. So here also we have a formula. So based on that, we can actually estimate the correlation between those two particular items. That is one how one is going to depend on the other two items, right? You'll see this formula, that is square root of, here I need, if I want to calculate this, I need to calculate these individual items also. What is those individual items is nothing but I need to calculate, this is actually first dependent on 2, so I need to calculate R12 need to be calculated. So how to calculate R12 we know, because we know this formula. So if this formula is known, R12 can be calculated. So first we have to calculate is R12 and I make it square, R12 square plus R13 square minus 2 into R12 to 13 and 23. R12, R13, R23. We have a derivation for each of these formulas, which is not our direct point of interest. So we have R12 the whole square plus R13 the whole square minus R12, R13, R23, the individual correlation parameters. Right, whole divided by 1 minus R23 the whole square. 1 minus R23 whole square. Right, by seeing the formula itself, it is very clear. What we are actually doing is we are taking the correlation, that is the squared correlation of R12 and R13. We are summing up those squared correlations and we are subtracting the correlation between 1, 2, 1, 3 and 2, 3. The individual correlations between 1, 2, 1, 3 and 2, 3. The linear correlations. I am separating that and everything is normalized by 1 minus R23 whole square. What is that 1 minus R23 the whole square is? R23 corresponds to the independent variable correlation, which we say should be as low as possible, because correlation between independent variables should be as low as possible. So I have 1 minus R23 squared. So the remaining thing, what is that is R12 and 13 correlation should be available. That correlation need to be present in the denominator. Ultimately, what I'm doing is I'm normalizing the entire parameter, right? So this is what the formula for a single variable dependent on more than one independent variable, right? So based on this, we'll be solving some problems. What will be given to us is they'll be giving us three kinds of things. First thing, what they will be giving us is zero order correlations. Actually, we call this as zero order correlations. So what is zero order correlation is nothing but those correlations which does not make any independent variable to be a constant. This is actually zero order correlation. That is, I mean this entire term. This is RDI is there, right? This is actually called as zero order correlation. Why? Because in R1 to be dependent on 2, 3, I'm saying R should be dependent on 1, 2 and on 3. It is taking like that. One variable will become a constant. So I don't want that to happen in a zero order correlations, where there is all the independent variable will be taken into account and there will be one influence on the dependent variable, right? So that is the thing. Now we'll be going directly into the problem for multiple regression. When it goes to partial regression, we'll have more intuitions on how to make a particular independent variable as a constant, right? Yes. So the thing is, the following zero order correlation coefficients are given. That is R12 is given. R12 is equal to 0.98 and R13 is 0.44 and R123 is 0.54. If R is not given, that is zero order correlation is not given, at least the summation values will be given, and you need to calculate by using this zero order correlation formula. I say here 0.54. Now we should be able to calculate the multiple coefficient correlations, right? So what you have to calculate is, say for example, I write calculate multiple correlation coefficient treating first variable as dependent and the second variable as independent. Right, this is what we have to do. Our first variable is 1 and the second variable and third variable also. And second and third variable as independent. So 2 and 3 are independent and 1 is going to be dependent, right? So we know the formula for R. We know that it can be written as R. If it is R is 1 is going to be dependent, I will keep 1 here, and it is going to be dependent on 2 and 3. So the independent variable should come after the dot, dependent variable should come before the dot. So R1.23 will be equal to what? Please join with me. What is the formula? What is the formula? What is the formula? Let me see how many times I need to ask this.
R12 square plus R13 square minus 2R12 R13 R2.
Yes, the same thing what we have written here, I am writing here. Only Abhinam is only student in the class, I hope. Okay. R13 the whole square minus 2R1, 2R13 and R23. So you have these formulas in the mind as much as possible. This and all you have to be in a position to calculate within 1 minute or 1.5 minutes. 1 minus R23 square. So what will be the answer for this? I just substitute here. The R1, R2, all the values I go and substitute here. R12 is 0.98 squared plus 0.44 squared minus 2 into R12, R13 and R14, 0.98 0.44. Anyone calculate the answer? And 0.54. right? 1 minus R23 the whole square. That is 0.54 square. Anyone calculated the numerator, or what is 0.98 squared? Can anyone?
0.9604.
This is 0.9604. Okay. 98 squared alone, huh? Okay, next 0.44 squared.
Numerator 0.688, sir.
Numerator fully up.
Sir.
Come again. 0.
0.688304.
0.68804. Okay, this is numerator, that is 98 squared plus 4.
304.
0.68604.
688,304.
Okay, 304. That is 98 squared plus 0.44 squared minus 2 into 9.98 into 0.44 into 0.54 divided by the denominator
0.7084, sir.
0.7084. Okay,
7084.
divided by 0.7084. So the final answer will be
0.971.
0.971. Great. Will it be possible to do this in 1.5 minutes or 2 minutes? One more square root of 97, maybe 98.
0.9856, sir.
0.9856.
56.
Okay. 9856. Great. Yes. So good. Right now, this is actually the correlation of 1 with respect to 2 and 3. If I ask the correlation of 2, keeping 2 as a dependent variable and 1 and 3 as an independent variable, what you will be doing? What will be the change here? Don't do the changes much here. Here, what will be coming here? So what will be the formula? If I put R, what will be the donation in notation will be coming here? Dependent variable will be 2, and what will be the independent variable?
1, 3.
Great. Formula, can anyone say? Full formula, can anyone say? What will be the change? This is a formula. So what is the change will be there here?
4, 3, R21 whole square.
Okay. Next.
Plus R23 whole square. Minus
Full
4R.
this. Great, great. Divided by 1 minus R 1 3 squared, right? So the change that come here is this. And one more thing I want to add here. I'll ask you itself whether the correlation between 1 and 2 and the correlation keep it because R12 R21 both are same, right? So here R21 is needed, so you can directly take R21 R23 and so on. That is what we are going to do now, right? Shall I erase the left hand portion here?
Sir, on what it is you wrote me, sir, zero order correlation inde-
Yes.
between independent and dependent. On what it is independent and in the sense
Yes.
what it is
So
independent, sir.
what is zero order correlation is none of the independent variable is made as constant. When I explain this partial correlation, one of the type of partial correlation is zero order correlations. What is zero order correlation is nothing but, for example, if I have that rainfall to be predicted by using temperature and humidity, the dependent variable will be rainfall, and the independent variable will be temperature and humidity. If for some reasons I want to make I want to neglect temperature from being considered for rainfall prediction, then what will be my answer is I have to make any one variable as the constant, because temperature I make it as constant because I don't take it into account inside my equation. I'm going to predict rainfall only with the humidity. Then it is called as one variable is made as dependent. Then it is not a zero order correlation, because one variable is made. I will give another name for it, like a single order correlation, like that. Likewise, if you have some more independent variables, though they have a significant impact on the dependent variable, but you don't consider that variable for analysis, then I make it as constant. So it will become two order correlation and so on. Here there is only one dependent variable and one independent variable, and now all the independent variables are taken into consideration. So I say it is zero order correlation. So that is what is depicted here also, R1 to everything. So I'll erase the left hand side portion. Right, now we have to calculate multiple correlation coefficient with second variable as dependent and first and third variable as independent. So already Usha said the formula. I'll enumerate the formula again here. R second variable is dependent. Dependent variable will come first 2 dot. After that, I'll put the independent variables. First and 3 are the independent variables. So 2 dot 1 3 is equal to, I write square root of R, this time R 2 1 squared plus R 2 3 squared minus 2 R 2 1 R 2 3 into R 1 3. Whole divided by 1 minus R 1 3 squared. Which will be equal, now we're going for the substitution. We already have it. We have R12 given in the problem. We need R21. Both are actually symmetric. So I take 0.98 squared plus R23 0.54 squared minus 2 into the same thing again 0.98 0.54, that is R23 next R13 is 0.44. All divided by 1 minus R13 square, that is 0.44 square. So we calculate this, we already have 0.98 squared everything. So only one change over in the numerator is 0.54 squared, which became the replacement for 0.44 squared. and denominator we have 1 3 square, that is 0.44 square. Can anyone tell what is the numerator for this? Yes, can anyone say what is the numerator?
0.7863, sir.
0.7863 will be in the numerator. Denominator
0.8064.
0.3
0.8064.
0.8064. Great. And the division of 78 by 80 around 0.9 something, right?
0.975.
75. And the result is
0.9874.
0.9874. Then similarly, you can easily calculate the next one, that is R3 with respect to 1 and 2. That is actually self-explanatory. You can easily do the source substitution and get the result. Right. So now, in order to throw more light on what is being asked about the zero order coefficient, let me take one example. Right. Please take the screenshot of this. Let us see about the types of those zero order correlation, everything. That is partial correlation and its types. Right, partial correlation by the word itself mean if I have a set of independent variables predicting a dependent variable, I'm not in a position that I should take all the independent variables into consideration for predicting the dependent variable, because I was actually having a more insight on my response time and the complexity, so I can reduce the number of independent variables what I have. So to do that, we have to make some independent variable, though they have a significant impact on the dependent variable, we make them as constant. So that is, making as constant is nothing but not allowing them to influence in the dependent variable. That is actually called as partial correlation, right? So this partial correlation can be considered as three ways. One is zero order coefficients or correlation coefficient. Second is first order correlation coefficient. Next is second order, and it depends upon the number of independent variable actually. Second order coefficients. Right, let us see with an example on what is each of those particular terms and how they are actually going to have an impact in their dependent variable. Right. This is actually simple correlation, a linear correlation between two variables. That is, one is dependent and other is independent. Correlation between two variables. The most important thing to understand here is no variable are held constant. Held constant in the sense there are some variables which are actually also having a relationship with the dependent variable, but I'm not considering that. That is actually, but here that is not like that. Only two variables are there. Both of them are taken into consideration, right? Right. Here also it is a correlation, and how can I represent it? Is one variable has been held constant. Here one variable has been held constant. Here I can also write some representations to understand this better. How can I represent this? Is I go to a pen, I take it. I can represent it as R12, R13, or 2 3 like that. If I that is only two variables are taken, and I don't say that here it is dependent, here it is independent, not like that. Just taking it, making it into consideration and working on with it. I'm not saying this is dependent, this is independent, there is no effect in these two. I'm not considering anything. Simple correlation between two variables, that is zero order coefficients. When coming to first order coefficient, see carefully what I'm doing here. This is a partial correlation. I take something like R12 dot 3, R12 dot 3. So far what we have seen in the multiple linear regression is 1.23, means that 1 is going to be a dependent variable and 2 and 3 are going to be independent variable. That is what we actually considered so far. But here what is going to happen, I'm having 1 2 dot 3, that is there are going to be two dependent variables and it is going to be making from an independent variable 3. So what actually in the ultimate having happen is, for example, you have, as in that we have three variables. There can be like I want to consider yield of rice or wheat something. I was in a farmland, assume, and I want to consider the different variables as how much wheat or how much rice the yield will be this particular month. I want to calculate, and I can calculate it by using rainfall and the temperature, right? But some studies show that yield and rainfall alone is going to be taken, and the temperature is not going to be taken into consideration. Right? This is what the first order correlation. There are two independent variables available. Say, for example, rainfall and temperature, predicting the yield of rice in the particular land in this particular season. But rainfall alone is considered and temperature is not considered. If it is not considered, it is actually meaning that it is made as a constant variable. So that is actually being represented in first order coefficient as this particular term. This particular term is actually being represented for the constant variables, right? In first order correlation, right? For example, if I having two items and I want to neglect one on the impact of one item, I just put it over here, and I don't want the influence of this particular item. You would have seen here before. When I write R1.23 in the previous example, we neglected the impact of R23, right? How we neglected? We just took 1 minus R23 squared and we normalized the entire correlation factor with 1 minus R23 squared, because the impact of R23 is not required for us, because the impact of independent and dependent variable is needed. The impact of two independent variables to their own correlation we don't consider, right? So this particular, the third variable influence is completely taken out. That is actually called as first order coefficient, right? Similarly, this one you can itself directly say this is nothing but two variables will be held constant. Two variables will be held constant, and I can actually write this particular thing like R1.23, or to be in more higher level, you can also write this like R12.34. I can also write like this. Means that this 3 4 variables influence is going to be made constant when I make the prediction with respect to R1 and 2. When I want to find R1 2 correlation with respect to 3 and 4, 3 and 4 is made constant. That is actually the second order correlation coefficients. Right? So far so good. Now understood what is the thing about this. When you have the ultimate is this: when you have more number of independent variables in predicting the value of a particular dependent variable, the influence of some of the independent variable can be made constant, and that can also be reflected in the correlation coefficient. That we call it as partial correlation. Right? So far so good. I am making it clear now what is zero order correlation coefficient, first order coefficient, and second order coefficient. Yes, I am making it clear now.
Yes, sir.
Yes, right. Formula and how to make 1 and 2 here. We know of directly giving you the correlation coefficient, what will be given is will be given with the summation values. That is this particular term, right? Initially we had like this, right? Any other formula is not available now. See, we had right R12 is equal to summation of x1 x2 divided by square root of summation x1 squared into summation x2 squared. Those values will be given. This particular value. How to calculate here R12 value is not given, then what will be given is the summation values will be given. Summation, the same thing. We initially we wrote a formula, right? The correlation coefficient between independent and dependent variable. That will be used. Summation x1 x2 divided by summation x1 squared into x2 squared, the square root. Right, like this formula can will also be used when sometimes if I ask you to find the R12, these values will be given. The summation of x1 into x2, summation x1 square, summation x2 square will be given, and then some additional variables x3 also will be given. And when I ask you to do R12 or R13 and so on, you have to be in the position to apply this formula and find the result. And for these problems also, if R12, R13 and R23 is not directly given, summation values will be given, and based on those values we need to do the appropriate calculations, right? So this can be easily done, right? If I ask any question with respect to that, the zero order coefficient as well as the first order second order coefficient with single dependent variable we can do, right? For these formulas I have given the formulas for that, and we can do these two, right? Yes.
Yes, sir.
Yes. Right. Then just to take the one thing, we have a problem here. Summation x1 squared will be 90. Summation x2 squared will be 160. And the summation x1 x2 x3 is also given. Summation x3 squared will be 40. Summation x1 x2 is given. It is 60 again. Summation x2 x3 60. Summation x3 x1 40. So like this a value will be given, and you should be in a position to identify what is the multiple correlation coefficient R1 given 2 and 3. R1.23. What will be the procedure? Can anyone say? If this need to be identified, what will be the procedure?
You need to find R12, R23, and R13.
Okay. First, initially, I need to find R12, R13, and R23 by using these individual summation values by substituting these formulas. This is for 1, 2. Like Shruti said, we need to calculate for individual correlations, zero order correlations. R12, R13, and R23 should be calculated. And based on that, the second order coefficient need to be calculated, right? Okay, just calculate it. We also discuss in the class next time.